I'm working for the Royal Netherlands Chemical Society, the KNCV, and welcome to this ChemDraw webinar, the first one that we do. And it's a Q&A and a webinar all in one. And we are very glad we are able to organize this webinar together with PerkinElmer to give you the chance to learn more about ChemDraw and ask your questions to our speaker directly. It's good that you're here because it's not up to the speaker alone today. It's also your chance to ask all your questions to the ChemDraw, all your ChemDraw related questions to our expert speaker. So please submit all your questions via the Q&A. That is the two small talking clouds in the bottom of your screen. You can we will use the chat only for technical problems or general comments such as thank you or great presentation. Our speaker today is a so-called ChemDraw Wizard. He is here to give you a glimpse into his craftsmanship and to answer any questions you might have about his magical skills. Without any further ado, I would like to introduce our speaker for today, Pierre Morieux. I don't know if I pronounced your last name.
Yeah, no, you pronounced correctly. You pronounced it correctly.
I will give the stage to you. Good luck and thank you for your time.
Thank you. Thank you, everyone. Thank you for joining. As Frank said, my name is Pierre Morieux. I'm the chemistry product marketing manager at PerkinElmer. Let me actually share my screen before we get into that. One little second. There you go. And wonderful. Can you see my screen, Frank?
Yes, I see your screen.
Okay, cool. So once again, I'm Pierre Morieux. I'm the product marketing manager for chemistry at PerkinElmer, also known on the internet as ChemDraw Wizard, for tutorial videos that I have been making for actually the past 10 years. It's almost 10 years I'm working for PerkinElmer. I'm joined, but she's not presenting, but I'm joined by Lindsay Rickershauser, who is the new product manager for ChemDraw, but I will be the person demonstrating ChemDraw today. So I heard that from Frank that there were no submitted questions prior to the webinar, which, well, that's okay. I have plenty of examples that we can go through. If you have specific molecules or specific challenges that you have and that you would like to get this addressed live, please do not hesitate to submit a question, and then I'll see what I can do to help you answer those. Obviously, as you can see from this introduction slide, many colors. There is something written here that says that we've released version 22 of ChemDraw and ChemOffice recently, with a bunch of improvements that I will demonstrate to you live. Before we do that, just have a little announcement to get across. We have launched recently a community website for our ChemDraw users called ChemAzing, and you can either remember this URL, which is chemazing.perkinelmer.com, or you can type ChemAzing on Google, and you will get there. And what this is simply a place where you can ask questions. We can get insights from other users using ChemDraw. And for example, just to show you, this is what it looks like. And we do our best from our side to answer those questions, and then to post things that we do with ChemDraw. And then of course the other users can answer that themselves. All right. Before we get to, for example, that sort of molecule, let's go into ChemDraw itself. Actually, let's do that. And so I did prepare Dutch examples. This is from a total synthesis of Trevor Hamlin, but from Free University of Amsterdam, who's quite active on Twitter. I know he likes ChemDraw, but I guess he's not here today. I want to start with the basics. Those are key intermediates from a total synthesis of a medangamine E. And I will be using those as guinea pigs for what I like to demonstrate. I like to demonstrate the basics. The basics of ChemDraw are, first of all, let me take this as a guinea pig. The basics of hotkeys and shortcuts. Let's start with shortcuts. Let's start with, you have this molecule you have made this molecule. How do you make quickly copies of this molecule? You simply select it. So multiple ways to select a molecule. First, let's start with that. With a selection tool, you double click on a molecule and select the molecule, or you press tab. Pressing tab is going to select the molecule you are currently interacting with. So let's say you press tab. And by the way, I'm sorry, normally I have an open source widget where you can see on the screen what I'm typing on my keyboard, but for some reason it's not working with version 22 of ChemDraw. That's something we need to look at. Not a problem on the ChemDraw side, but more on the open source widget. So that's why I'm trying to vocalize and say everything that I am typing on the keyboard, but I may forget a few of those. I'll do my best to say everything that I do. So rather than Control-C, Control-V, which you may be using to make, if you want to make copies of molecules, you hold Control, you select the molecule, you hold Control, you see a plus sign that appears over the hand, and then you can simply click and drag to make multiple copies of molecules, for example. Okay, so let me Control-Z, undo that. That's one thing. When you move a molecule with the mouse and you hold Shift, you can strain it to the X or the Y axis. You can strain it horizontally or vertically. So if you hold Control and Shift and then you click and drag, you will make aligned copies of your molecules, very simply. For example, like that. Let me delete. Take this, for example, this molecule that you want to have here. So we're going to go into shortcuts, but before we go into shortcuts, there are actually a few toolbars that you will see on my screen that I want to make people aware of. So this is the general toolbar. It's the basic actions, copy, paste, undo, etc. It also includes this little icon, which does something very nice if you are on the ChemOffice level of our offering. I'll demonstrate that in a second. The second toolbar you see, that is one of the most important ones, is the structure toolbar, which you can enable in the view show structure toolbar. That's what I have. Then on the right, we have the object toolbar. So icons corresponding to what you can do with in terms of object actions, and that you can enable in view show object toolbar. And then there are the add-ins toolbar. So if you are on, let's say, ChemDraw Professional and version 21, 22, you will have the Reaxis add-in, you have the SciFinder add-in, and then this is the SciFinder N add-in. And if you're on ChemOffice, then you also have access to 2 additional add-ins, which are the PubChem Safety, GHS information, and HNP phrases, and the Google Scholar Google Patents add-in, which looks for your molecules by substructure or exact structure search inside Google Scholar Google Patents. Okay, those are my main toolbars. So for example, what I want to do here is, let's say I want to distribute things nicely. So you can either in the object toolbar use distribute horizontally, like that, to evenly space the various objects or molecules that you've selected. If you let me undo, it's Control Shift Alt, the 3 modifier keys, with H or V. H for horizontal, and press Escape to show. Okay, so the only thing about that is that it interferes with zoom shortcuts. So I'm gonna not use that shortcut, and I'm just going to tell you that Control Shift Alt and then H or V is for horizontal or vertical distribution of objects, respectively. Okay, so that is for basic cloning of molecules and making them look nice on your screen. One additional trick, if you want to go into a specific trick, is you can move a molecule by a certain amount of pixels, and then you can hit Control Y. Control Y is going to repeat exactly the last action that you did. So as you press Control Y, it's going to shift the molecule that you have, again, by the exact same amount of pixels. One application is if you want to make something that doesn't go completely straight. Control Y repeats the last shift, that you have done for that. Those are for the basic object handling shortcuts. Right. Another one that is actually quite helpful is, excuse me, I'm just looking at, I had that publication ready. Anyway, never mind. We are going to continue with shortcuts. So you have a molecule selected. You hold Control on PC or Command on the Mac, and then you press arrow right, down, left. That's the reaction shortcut. The reaction shortcut is going to take whatever you have selected and clone it on the other side of a reaction arrow, whichever arrow you have selected here, right? So I have selected this one, so the reaction shortcut is going to use that sort of arrow. Those are some of what I would call the most important shortcuts. And let's make a little modification here, because that's I'll get into that in a second. This you can combine shortcuts with hotkeys. So before we get into that, and we cover the basics of hotkeys, I just want to add a few, remind you. In version 20 or 21 or 22 of ChemDraw, you have a hotkeys cheat sheet or shortcuts cheat sheet, right? So the hotkeys cheat sheet is normally the first thing that pops up when you first launch ChemDraw. And this is the version 22. So it tells you everything that's going to happen to an atom if you press 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc., etc., etc. We're going to see that in about a second. Same thing for bonds. If you are over a bond and then you press W, H, B, capital B, D, capital D, etc., you will get those actions. And then I'm going to quickly talk about the newest additions to the hotkeys and the shortcuts for version 22. The one that I want to emphasize is going from a selected molecule to hotspot editing. So for example, if I go here, when you have multi-step synthesis, you select the molecule, you press, so you press tab, you do Control arrow right, then you press enter. Pressing enter is going to go from select selection of a molecule to editing the molecule with the hotspot. And so you can take a molecule like this, you can do that, you can press enter, and you can make changes. You can, for example, flip around the various groups and continue doing that. That is to say, do that, and maybe reduce that double bond, and continue making modifications, selecting, and so on and so forth. So this is a really quick way to draw multi-step reactions easily, and easily drawing complex synthetic steps. Okay, any questions so far? I see there's a question from Maurice. I will answer that a little bit later, but on what you have seen so far, are there any questions? I assume, Frank, that anybody can unmute themselves and then speak if they need to.
People can either raise their hands and I could
Okay.
give them a voice, or they could use the Q&A or the chat.
Okay.
There's a question in the chat from Martin. Let's see.
One little second, because
This question is, can we download the hotkey paper somewhere?
Directly from ChemDraw. Directly from ChemDraw. Well, actually, it's not downloadable. That's a good point. It's a good suggestion. So if you have version 21 or 20 or 22, you can, get it and print it from ChemDraw. It's not downloadable per se, but it is available here in the help, hotkeys, and shortcuts. Those are the shortcuts. Some of them I have shown you live, and that's where you would get them. Hope that answers the question. Okay. So briefly, what I want to quickly show what the basics of shortcuts, the basics of hotkeys look like. The principle is that there is what you see on the screen. There's a hotspot. The hotspot is the equivalent of the text cursor in Word. For example, you move the cursor with the arrows on your keyboard to decide where you're going to insert the next letter when you type a text. So that's the hotspot that you see. It's movable by the arrows on the keyboard. So you don't see, but I'm just typing left and right on my keyboard and pressing, for example, 1, the numeral key 1, or 0. So the principle is 0 goes towards the green dot, and 1 goes away from the green dot, right? 1 towards green dot and 0 away from it. So 1 extends while 0 cyclizes. It's pretty much the logic. And many things that you can do there, but in a nutshell, if you press 2 over an atom or bond, you'll get a carbonyl. If you press 3 or A, you will get a phenyl. If you press 4, you're going to get the wedged bond. If you press 5, you're going to get hashed wedged. If you press 6, you're going to get a cyclohexyl. If you press 7, you'll get cyclopentyl. 8, a double bond. 9, you will get a dimethyl. And everything I'm showing you is, for example, if I'm on a secondary carbon, right? So things are context sensitive. So if you press, for example, 9 on a primary carbon, you get a dimethyl like this. Whereas if you press 9 on the secondary carbon, you will get a gem dimethyl in this orientation. A dimethyl, and well, adding a dimethyl in this orientation. Okay, If you are into more advanced, well, not more advanced, more complex structures, you can press, for example, V to add the cyclopropyl. So imagine you add the cyclopropyl, then you press O, you have your epoxide directly added. You can press U, for example, to add a cyclobutyl. You press U, and then you press O, and you get an oxidane, and so on and so forth. So all of that is summarized in the cheat sheet. And of course, those are, let's say, some of the functional group hotkeys, but then the ones that you probably know are O for oxygen, right? But it's also case sensitive. So capital O is an O-methoxy. Then there is N for nitrogen. Capital N is nitro. Let me go to formula here. Then what? Then we have S for sulfur, but capital S for silicon, right? And then what do we have? We have F for fluorine, but we have capital F for trifluor. And I don't know why it's giving me that warning. This is something I'll need to discuss with Lindsay maybe. And then we have B for bromine, and we have capital B for boron, and so on and so forth. So P for phosphorus and capital P for phenol. Those are, let's say, the basic hotkeys for the basics of hotkeys for ChemDraw. Okay, so with that, you can actually draw complex molecules quite easily. Let's take this molecule right here. I can start from wherever I want. Actually, pressing Enter is going to start the text tool over an atom. So I type BN, then I press N, then I press 9, then I press 2, then I press 5, then I press N, then I press 1, then I press 2, N, 1, 6. I go down, I press, actually not 5, but 4. Then I press N. Now over a bond, it's H, hashed wedged for the bond. I go here, I press S to change it to sulfur. Capital K is actually a T-butyl. It's a recent hotkey. And then M is for methyl. Okay, so you can take this and Control-Shift-K. Control-Shift-K is the structure cleanup. Also now that I like to call it the 2D cleanup of structures because we have a 3D. Control-Shift-K or Command-Shift-K on a Mac is going to clean up the reaction. Okay. Any question on that? I'm sorry, Frank, somehow the chat and the Zoom
No problem.
Disappeared.
I'll take a look.
I think my Zoom meeting toolbar just disappeared because of the shortcut that I typed, I think.
Oh, yeah. I don't see any incoming questions apart from the Q&A question from Maurice that was already there, but you'll get to that later, I guess.
Yeah. Well, I mean, I can answer it right now. So adding extra tools for Newman projections. For Newman projections, we don't plan on having any tool per se, but let's say this is something that you could use the new 3D cleanup tool for. So I don't know if the ask is more templates or different ways to
I can allow Maurice to talk, and then we can ask him.
Sure, let's do that.
Verify.
Hello. Can you hear me?
Yes, good afternoon, Maurice.
Hi. So yeah, I was wondering. It's usually pretty difficult to draw Newman projections. And yeah, you said you could use the 3D tool for that. How would you do that?
Let me. So I don't know. Let me take a molecule like this. You can see on the screen. So I'm gonna do. Sorry, let me go to another page. I take this molecule, right, and then. So I'm gonna take this, and maybe. So, what am I doing? A capital K on a secondary carbon is going to give you a gem dimethyl with the stereochemistry. Okay, so that's just something for you that is nice for you to know. So I take this, I make a copy, and then I do the 3D cleanup. So the 3D cleanup, you need to be on ChemDraw Professional for that. It's since version 20, and we keep on improving the algorithm every version. You take that, you do Control-Shift-D or Command-Shift-D on a Mac, or you press the icon here in the structure toolbar multiple times, and then you're going to get an actual 3D molecule. Okay, so looking at it like this, you get your Newman projection. Now, how would you turn it? You select everything across. You select everything but the middle bond, and then you can rotate it with the rotation tool, structure perspective tool, right? So you could do something like that, right? And then you select it, and then you turn around again. Is that something that could be?
Oh yeah, definitely. Yeah, that helps a lot. And
Okay.
yeah, so the second part of my question was usually when you're drawing like sugars, it like ChemDraw doesn't recognize like the bond angles that need to be used to get like proper axial and equatorial.
Yeah. We
bonds.
know we have it on the backlog to improve the perception. Yeah, the bond angles on chair conformations.
Okay.
Not there yet, but we are aware. We're aware of that.
All right. Thank you.
Sure. So in your case, I mean, that's a good suggestion. Thank you for reminding me of that. So, you know, one thing could be that you can add colors, right? So to get the highlight colors, for example, you go to colors and then show highlight and show ring fills. Now, full disclaimer, let's say the z-axis perception is not 100% there, and we know we have some things to change. So the colors, the purple should be at the front, so the purple should stay at the front. It's all dependent on the perception of the bonds themselves. So in ChemDraw, when you are over a bond and you press F, you push it to the front, and that is going to, let's say, take the color attribute of the bond and put it to the front as well. So that's how you would, for example, use that in this case. That's for Maurice. Okay, so but I guess even without the colors, that could be already helpful for you. Okay. Which is actually a good segue for me to go into, let's say, more 3D cleanup options with it's a Dutch molecule to me from Professor Veringa at the University of Groningen, if I pronounce that correctly. And that's one of the molecular motors, right? So how would you easily do that from here. Insert a bond, go over the bond, press 5, and then move with the arrow. You press A over a bond to fuse a benzene ring. When you see things jump, if you are using the hotspot, is that shift arrow moves the hotspot, makes it jump further away, including wrapping up around the molecule. What I mean by that, if you're not following what I say, is you see the hotspot that I'm here on the right part of the molecule. If I do shift right, I end up on the left part of the molecule, on the opposite side, right? So if I am here on this fluorine molecule and I'm on the right and I do shift right, I end up on the left. So when you finish drawing in a long molecule, instead of going all the way following the chain, you can simply jump to the other end, if that makes sense. So then you press 8 for a double bond, you press 7, and then you go here and you press 4 to get a wedged bond. You press, for example, capital K to get a T-butyl. Then you press A, and then you press A. Okay, so that's your 2D molecule. And now what I can do is 3D cleanup, right? Multiple times. It's important to do it multiple times because it's an energy minimization action. And every time you click on the icon, or every time you click on the icon, it's going to do 10 steps of energy minimization of the molecule. The first steps is just a crude energy minimization, and then the other ones are more refinements. So then as you click the 3D cleanup, automatically the structure perspective tool gets selected, and then you can move things around in space. There's a new shortcut we introduced in version 22, which is Shift, Alt, and arrows. So before that, simply Alt and arrows is the rotation shortcut. So you hold Alt and then you press down or up. It will rotate the molecule in the plane of the canvas. And then up and down is by 15 degrees increments. Left and right is by 1 degree increments. So that's rotation in the plane of the canvas. Shift and Alt now in version 22 actually do the 3D rotation by, if I remember well, 12 degrees increments. So up and down is in this axis, and left and right is in the other axis. Okay. Should you ever need to get the chiral version of that, you can simply take this and then go to Object and then flip. A little disclaimer on things that we changed. Before Control-Shift-H and V, before version 21, used to be a mirror flip operation. So you would actually get, if you had something chiral, you would get the actual enantiomer, or the enantiomer of the molecule you had selected. Now, and because we've listened to our users and we know that when you try to rotate the molecule, you don't want to get a different molecule. So we have switched the shortcut to be rotate 180, right? So it would still remain the same molecule, just rotated 180 degrees. If you flip is actually a mirror flip option. So if you flip horizontal, right, then that is a different molecule from the one that we're looking at, right? So this one is this naphthol group going up, going towards us, and the T-butyl going towards us, whereas this one is the naphthol going backwards, and then the T-butyl going backwards. To facilitate all of that, to facilitate visualizing all this, you can do select molecules, make the colors visible, and then go to here, and then maybe we can make that green and make the bottom one red, and the same here. Okay. And pressing tab, sorry, I forgot to mention that tab, you can select the molecule, but by pressing tab or shift tab, you actually select and go from one molecule to the other, right? So let's say we take this one and we make a color highlight like this. There we go. So it facilitates the perception of color. Let me remove this one. There's nothing that prevents you from adding extra, let's say, strokes to further impress that the perception of depth. That is to say, you could go here and press B over a bond to make it bold, capital B to make it bold double, to further enhance the perception of something going towards you, or not, right? And then you press 1 and 2 over a bond to make them go back to normal. So from here, one thing that I want to show, those are all features you can get into ChemDraw Professional if you are using ChemDraw Professional. In ChemOffice, you have this feature called the 3MF export. You can copy as a 3MF, 3MF being a 3D printing format, right? So let me take this guy and do a mirror flip, and then an actual rotate 180. So it's exactly in the same confirmation. What does the 3MF, so beyond 3D printing, right? That I have the webcam on, so you can actually draw something in ChemDraw. You can, with the 3D cleanup in ChemDraw, you can actually make a very nice trefoil knot of benzene rings. That's something that a Japanese research group made and 3D printed. Hope you saw this. The other great advantage of the 3MF format is that it's natively supported by PowerPoint. That is to say, you take this molecule, you copy as 3MF, you go into PowerPoint, and I'm in PowerPoint, and you do Control V, and you have your molecule the molecule that we were just looking at. Let me put that right here. Let me take the other one. Let me copy as 3MF, Control V. So that's the enantiomer. And the nice thing about those models is that they're native 3D models within PowerPoint, right? You need an Office 365 subscription to have access to this feature, but if you have an Office 365 subscription, then you have the support for 3D models. And what it means is that directly within PowerPoint, you have a handle to move the molecule on your slide, right? Like this. And the nice thing is that because it's PowerPoint, there you have native sets of animations. You have native sets of animations with effect options, so you can make them turn, you can make them swing, you can make them jump and turn if you want, going up, going down, right? So plenty of things you can do. And you can do that, and then you can make this one turn as well towards the right, and then you can make them go at the same time, right? Anyway, some pretty neat things that you can do. And if you have used the feature in version 21, you may have noticed here that now we're also transferring the ring fill colors. So in version 21, we were only transferring the color highlights. That is to say, the blue part of where's ChemDraw? Here, the blue part of the molecule here. But now we have also extended the transfer of colors to the ring fills. So the ring fills get sort of like a transparent plastic film wrap around any closed shape. Okay, that is for trying to be mindful of time. That's an important improvement in the ChemOffice 22. Other things we've added with version 22, if you are into nucleic acids or peptides, you have this that is called the Helm toolbar. Helm is a notation for biopolymers that is becoming an industry standard used by, well, it was developed and also it's used by pharmaceutical companies to represent well, natural and less natural amino acids and nucleic acids. And we've added, if you are using that, we have added a setting that makes those biopolymers more visually appealing. Let's just put it that way. So it's a document setting that you can go to, applying document settings from sequence graphic monomers. And it's actually going to turn this into what we call the cartoon representation. So that is to say, peptides are going to be circles, and each amino acid is going to have its own color. And then you can have the DNA, right? And DNA and RNA are represented by a triad, right? The D is deoxyribose, the P is for phosphate, and then adenine, cytosine, guanine, different bases. This is how you represent the nucleic acids in the Helm representation. Okay, and they're now more visually recognizable. That is another improvement that we have made in version 22. And another thing that you can do is opening CIF files. So that is something you can do actually at ChemDraw Prime level. If you have a CIF file, you can go to File, Open, and take one of those. I think this one. This is a crystallographic file. And you can open those now in ChemDraw. So one thing that you will immediately notice here is that all the hydrogens are explicitly drawn. And because that can be a little bit overwhelming, we've added in the structure toolbar this toggle hydrogen display, specifically for CIF files. So if you have explicitly drawn CH bonds, then you can simply turn those off when you're trying to view a CIF file. Okay, so that's that. And because we are into the new features. Oops, adenine and Okay, so if we do this, for example, one thing that we've added is an actual dedicated hydrogen bond tool, right? So it's right here. It's below the double bond, and we have the hydrogen bond tool. Hydrogen bond tool is for now it doesn't do too much, but it's going to do more and more in the future. It's to properly designate a hydrogen bond, right? So it has directionality, and it gets registered in the ChemDraw data format properly as a hydrogen bond. Why is it important? I'm just showing you an example here of, let's say, simple illustration example between adenine and thymine. Where this is going to come into play in the future as we continue improving things is that in the representation of biopolymers, this tool is going to allow base pairing if you have a double-stranded DNA, or if you have, for example, double-stranded DNA molecule that is chemically modified that you want to represent using the Helm representation we just saw, then this tool is actually going to capture the hydrogen bonding information. Also in the future, hydrogen bonds will be able to, you'll be able to add hydrogen bonds when you do the 3D cleanup, and it will influence the general orientation or the way that the molecule is going to be energy minimized. Right. That's what I wanted to go over for purely ChemDraw. Of course, I mean, I could go on for hours on ChemDraw, but I'm trying to be, have everything into 1 hour. Before we go anywhere else, I want to add a last thing, which is if you are, I don't know too much about the audience, so I don't know if you are students or professors or you're working in industry, but for, let's say, if you are working at a university and you have a ChemOffice site license at your university, you have access. Now we're giving access to the full version of Signals Notebook. If you need to capture your research in an electronic notebook that is powered by ChemDraw, you now have this available for you through your subscription. This is something that you should be aware of. Briefly, what's Signals Notebook? It's a cloud electronic lab notebook that is built with ChemDraw. So it's really about, you need a web browser, you need login and password, and then you can start capturing your experiments electronically. You can add an introduction text, you have templates that you can create, you can draw reactions directly in here, or you can copy paste from ChemDraw desktop. You have a stoichiometry table with that where things get calculated automatically. You can add multiple reactions. You can add a protocol, which equipment you are using, and various samples that you're going to create and analyze from this experiment. All of this in an electronic and structured way. That is why things are important. And then, of course, you can, for example, drag and drop PDF documents. You can drag and drop Word and Excel and PowerPoint documents to your experiments. And then you can share and do plenty of things. So this is something that you just want to mention you have available if you are at a university and using ChemOffice as, if you're at ChemOffice level. Along with Signals Notebook, you get this new application called ChemOffice Plus. ChemOffice Plus is a chemistry communication tool that lets you, among many other things, is designed to help you reuse content that you have already done. So for example, here we're looking into folders. Those are Word documents. Those are chapters from my PhD thesis from 12 years ago. And those Word documents, I have pasted ChemDraw drawings 12 years ago. And here I can select a document and then I can view just the drawing without having to remember if that drawing is on page 25 or page 48. And if I want to reuse that drawing, I can simply, for example, hit copy to clipboard and go into ChemDraw and do Control V, and I can repurpose that drawing as I want it. Or if I don't want the drawing, I can actually look into break this multi-step reaction into individual reactions, right? And if I just want this reaction, then I copy just this reaction and then I paste it here, right? So it's actually just this one that I wanted. That is one of the things it does. It's there to help you repurpose, recycle content that you have already drawn. You can select a document and view drawings, view only reactions, view individual structures. And it's a cloud application. It's sharing the same cloud as Signals Notebook, which means that you can search for, in Signals Notebook, you can search for Word documents, you can search for Excel documents that contain certain substructures, right? Or you can look for experiments in Signals, your experiments in Signals Notebook that have certain substructures. And from there, so let's say, this is one of the reactions that we just looked at. I select it. I know it's coming from Signals Notebook. That's the experiment name. That is the solvent. That is the volume of solvent. That is the pressure, temperature, reaction time, various equivalents, and yield of the reaction. And the goal is to help you manage your chemistry by being able to take either reactions or simple molecules and manage them into collections. So collections are simply a molecule with various properties associated with them, and it's designed to help you manage your molecules. You can type the various properties yourself and select one or multiple rows or all the molecules that you want, and then export them, for example, to a PowerPoint, right? So for your weekly reports, you want to quickly create a PowerPoint report where you show those are the molecules I have made this week, those are their properties. I don't need this one, I don't need this one, and I want a 4x4 column. And maybe I want things displayed below the structure, right? And then I can export this using this format. And there you go. So now I can show that. And in one click, I generated a quick report. We call it a throwaway report of the various molecules with the various properties, so that when you need to present something to your peers, to your manager, those are the things I have done in the past week. It can now be done in a few clicks, as opposed to you having to scramble and copy paste from various documents, from various emails, the various molecules that you have been working on. Okay, that concludes what I wanted to show you today, right?
We have an additional question, Pierre.
Yes.
Someone anonymously asked, I always have difficulties drawing metal complexes like, for example, allyl palladium chloride or bis allele nickel.
Yeah.
What's the easiest way to draw these?
So delocalized alleles. If that anonymous person would be so kind to leave an email address, because I don't think I'm going to have time to. If we have 5 minutes left, I don't think I'm going to have time to show this live. I mean, I'm eluding the question a little bit, but the 3D cleanup works well with metal complexes. Now with allele types of ligands, delocalized, you would have to maybe find some tricks. So let me see. And also, you know, it's been a while since I've done organic chemistry, so forgive me if I don't have the right one that's coming out of my head immediately. But if you do a COD ligand, because that one I know. So let's say I'm going to show this, and I hope it's going to work. And if you can leave your email address and give me examples by email, I'll look into them. You insert a bond, you press 8 over the bond, and then you press 2, and then 2. Okay, so that's your COD cyclooctadiene sort of ligand. What happens if I do Control-Shift-D on that? Right, if I do Control-Shift-D on that, it's going to do something like this. Now, the way to represent, you know, an actual metal being complexed here would be that you do this and whatever. I don't remember if it's nickel for this, but you take that and then you do Control-Shift-D, right? And that is going to give you, in that case, a complex nickel with the COD ligand. So how would you do this with a delocalized allele? You would need to find a way, if you can find a way to reproduce the geometry, the expected geometry with carbon bonds, like I'm doing here. You see, I took 2 cyclopropyls and then put them together, and I put the nickel there, and then in the end, you know, you could simply make those bonds dashed. Sorry. So if you press D over a bond, you make it dashed. Well, if that does this help in any sort, what I just showed? The anonymous person.
Yeah, I don't know who the anonymous person is, of course. So that's if you want, if you have any follow-up questions on this, or you could send me the further questions. Would that be okay, Pierre, that I collect them and then send you some further questions if people still have them? And there's another anonymous attendee that says, a simple question: how do you easily connect 2 molecules together without a new bond, without getting the red X box error?
Very simple. Very simple. Let me. So let's imagine I have this, and then I'm just taking the example that I take for calyxarine, for example. So you control click and drag, and then you drop the clone essentially you very closely overlap the carbons you want to be joined, right? So this one has the red error, as you just said. Do this again and again and again, right? So you drop it, Control Y, Control Y. So here we have 5 different molecules, right? 5 different molecules, 1, 2, 3, 4, 5, that have closely overlapping carbons. So you select all of that, you press Control J to join, and now we have 1 molecule. So all, if you select multiple molecules, all the very closely overlapping carbons, and I mean it needs to be very closely overlapping, will become joined at once. Example, adamantane, right? Adamantane in 2D, which looks not super great. Control Shift D, that looks like more textbook adamantane. Rotation shortcut. And I take this, I select Control, click and drag. And it needs to be really well overlapping, right? Control Y. And select and Control J. There you go. So now it's 1 molecule. Hope that answers the question.
I guess it does. Well, I added a final comment in the chat, so you can send any further questions you have to me. If it's too much, we might think of having a second session. We'll talk about this with Pierre and his colleagues. And we'll see if there's the need for it within our members. I guess thank you for your time, Pierre. I think it's cleared up a lot. For me, it was very interesting to see. Well, especially the PowerPoint features with all the colors look really, really nice.
Yeah, no, it is. It is really.
People use those for their presentations because that might make the presentations that we see a lot even more interesting to follow.
Yep.
Well, thank you for your time. I see a lot of thank you for the presentation and awesome thank you in the chat and Q&A. So
okay,
I guess you were very clear and it was appreciated. Thank you.